rationalize the denominator, all variables represent positive real numbers. We have here some fourth roots of stuff, right? Fourth root in the denominator is the one that we want to rationalize. We want to get rid of that fourth root. And the way we have for getting rid of fourth roots or square roots or cube roots or any such root is we're going to multiply by 1. Of course, this one is a rather boring one and not a very effectual one. So instead of just 1, the numeral, we're going to use something equivalent to 1. We're going to use something divided by itself. And what I'd like to use is whatever it takes so that the product of this and that, what I'm about to write down, or try to write down, so that that product is something that doesn't have any roots in it, so no fourth roots. So what I would like to have, in order to get those fourth roots to cancel, I would like to have, after I've multiplied, a fourth root of something to the fourth power. So I have some factors underneath the fourth root now. I'd like to have, instead of these particular factors, I'd like to have the same types of factors, so still 3's and still b's, but instead of a 3 to a first power and a b to the second power, I'd like to have a 3 to the fourth power and a b to the fourth power. And if I have that, well, now I have something to the fourth power under a fourth root, and that fourth root and that fourth power are going to cancel. So I need to go ahead and multiply by a fourth root of something, right? And if I have a fourth root of something and a fourth root of something else, I'm just going to multiply the radicands together to give me this. So I'd like to multiply by something here so that after I've done the multiplication, I have a 3 to the fourth power. I have 1 3 here. If I did a 3 to the third power underneath this fourth root, then that part of the product gives me my 3 to the fourth power. So that's nice. I'm also going to need to have a b to the fourth power. I currently have a b squared, so what I need to multiply by is by another b squared. So b squared times b squared is going to give me my b to the fourth. So this is the right thing to use, the fourth root of 3 cubed times b squared. If I put that in the denominator, I also have to put it in the numerator so that I am multiplying by 1, something divided by itself. Right? And in the numerator, well, I get something. This product, whatever that product might be, it's a fourth root of, I have a fourth root and another fourth root, so I can just multiply the insides, a times 3 cubed times b squared. So we get that. Let's write one more step. Let's cancel that fourth root and that fourth power so that we've done what they've asked us to do here, namely to rationalize. So we got rid of that fourth root and that fourth power by writing that there. Our numerator, we can't do anything else to that. In order to factor something out from underneath that fourth root, we would need to have a factor of to a fourth power, and we don't have any such thing. We have third powers and first powers and second powers. So nothing's going to pull out of that fourth root. So this is the best that we can do. I mean, it's pretty good. I mean, we got rid of our root like they wanted. In general, I'm going to ramble on for an extra minute now. In general, when we're rationalizing something, we're trying to make the denominator look nice. And in order to rationalize, we have to multiply by something. And to multiply by something, we have to do the same thing to the numerator, so that we're multiplying by 1. And so our denominator, we're aiming for a particular goal, and our numerator is just have what you will. Whatever happens up there, happens up there. So we should never expect our numerators to multiply out nicely. Sometimes parts of it will be nice. Sometimes it'll look pretty. But in general, we should expect it to still have some fourth roots of stuff and have elements of the roots down here and elements if there was roots up here. So we had some b cubes, b squareds down here. We expect to see some b squareds and stuff up there, which we do. So we should never expect our numerator and our denominator to look nice. This whole act of rationalizing and somehow takes all the bad parts, quote unquote bad parts, these root parts, and it moves it up into the numerator. In the denominator, they end up disappearing because I'm using exactly the right thing, right? And in the numerator, well, I have to put stuff. I just store this fourth root of stuff. So we don't expect the numerator ever to look nice. So there's our nice simplified form of this rationalized denominator.